All wires running through wall cavities must be stapled within 8 inches of every electrical box, junction box, or other point of termination. There is an exception for wires entering a box through a hole drilled in the stud directly behind the box. These wires are not required to be stapled within 8 inches of the box if the following conditions are met. Firstly, the distance from the hole to the nearest staple beyond the box is less than 4 inches. Secondly, the wire is supported at the point of entry into the box. Given that the wire is going to the outlet and is coming through a hole in the stud less than 4 inches away, the wire needs to be stapled within 8 inches of the outlet box. However, the staple can be located in the stud directly behind the outlet box, ensuring that the distance from the hole to the staple is less than 4 inches. Always check local electrical codes for specific requirements, as they may vary slightly from the general rules stated above. The purpose of stapling is to secure the wires and prevent them from being pulled out or damaged. Staples should be driven flush with the surface to avoid damaging the wires. Considering the proper installation of electrical wiring in walls, understanding the National Electrical Code, or NEC, requirements for stapling is crucial for safety and code compliance. The general rule mandates that all wires running through wall cavities must be securely stapled within 8 inches of every electrical box, junction box, or any other termination point. This regulation aims to prevent wires from being unintentionally pulled out or damaged, which could lead to electrical hazards. However, there is an exception to this rule that applies when wires enter an electrical box through a hole drilled directly in the stud behind the box. In such cases, the wires are not required to be stapled within the standard 8-inch distance from the box, provided that certain conditions are met. The first condition is that the distance from the entry hole in the stud to the nearest staple beyond the box must be less than 4 inches. This ensures that the wire is secured relatively close to the box, preventing excessive movement or strain. The second condition stipulates that the wire must be adequately supported at the point where it enters the box. This support can be achieved through various methods, such as using cable clamps or other approved securing devices to prevent the wire from sagging or being pulled out of the box. In the specific scenario where the wire runs to an outlet and passes through a hole in the stud that is less than 4 inches away from the box, the wire indeed needs to be stapled. However, the placement of the staple can be strategically positioned on the stud directly behind the outlet box. By doing so, it is essential to ensure that the distance from the hole to the staple remains less than 4 inches, complying with the exception to the general stapling rule. While these guidelines are based on the NEC, it is crucial to remember that local electrical codes may have specific requirements that vary slightly. Therefore, it is always advisable to consult the local electrical codes and regulations to ensure full compliance with all applicable rules. The primary purpose of stapling electrical wires is to secure them properly and prevent any potential damage or disconnections. When installing staples, it is crucial to drive them flush with the surface of the stud or framing member to avoid damaging the wires. Overdriving staples can compromise the insulation of the wires, increasing the risk of electrical shorts or other hazards. In summary, adhering to the stapling requirements for electrical wiring in walls is essential for ensuring safety and code compliance. While the general rule requires stapling within 8 inches of electrical boxes, the exception for wires entering through stud holes allows for more flexible staple placement, provided that the distance from the hole to the staple is less than 4 inches and the wire is adequately supported. Remember to consult local electrical codes for any specific requirements and to drive staples flush with the surface to avoid damaging the wires. Proper stapling techniques contribute to a safe and reliable electrical system in residential and commercial buildings. Furthermore, when working with electrical wiring, it's important to consider the type of cable being used. For instance, non-metallic sheath cable, commonly known as NM cable or Romex, is widely used in residential wiring. This type of cable consists of 2 or more insulated conductors wrapped in a non-metallic outer jacket. The NEC specifies the allowable spacing and support requirements for NM cable, depending on the size and type of cable. For NM cable, staples or cable ties should be used to secure the cable to framing members at intervals not exceeding 4 1/2 feet. Additionally, the cable must be supported within 12 inches of every box or enclosure. These support requirements help to prevent the cable from sagging or becoming damaged over time. When running an M cable through bored holes in studs or joists, the cable must be protected from abrasion. This can be achieved by using grommets or bushings to line the holes, preventing the cable from rubbing against the sharp edges of the wood. In addition to an M cable, other types of cables, such as armored cable AC and metallic sheet cable MC, have their own specific installation requirement. AC cable consists of insulated conductors wrapped in a flexible metallic armor, while MC cable is similar but has a smoother, more durable outer jacket. Both AC and MC cables require the use of approved connectors and fittings to ensure proper grounding and protection. When installing AC or MC cable, the cable must be supported at intervals not exceeding 6 feet and within 12 inches of every box or enclosure. Additionally, the cable must be securely fastened to the framing members using cable straps or clamps. The NEC also addresses the issue of cable bending radius. All cables have a minimum bending radius that must be observed to prevent damage to the conductors or insulation. The bending radius is typically specified by the cable manufacturer and is based on the size and type of cable. When making bends in cables, it is important to avoid sharp or abrupt bends that could compromise the integrity of the cable. In addition to stapling and supporting cables, it is also important to consider the routing of cables through walls and ceilings. Cables should be run in a neat and orderly manner, avoiding any unnecessary twists or turns. When running cables through fire-rated walls or ceilings, it is essential to maintain the fire resistance of the assembly. This can be achieved by using fire-rated cable and sealing any penetrations with fire-resistant caulk or sealant. Proper grounding is another critical aspect of electrical wiring. All electrical boxes and enclosures must be properly grounded to provide a safe path for fault current in the event of a short circuit. Grounding can be achieved by connecting the metal box to the grounding conductor in the circuit. Additionally, all metallic cable sheaths must be bonded to ground to ensure that they are at the same potential as the grounding system. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, bonding methods, and grounding electrode systems. It is essential to follow these requirements carefully to ensure a safe and effective grounding system. Another important consideration when wiring outlets and walls is the height and spacing of the outlet. The NEC does not specify a minimum height for outlets, but it does require that outlets be installed so that no point along the floor line is more than 6 feet from an outlet. This requirement is intended to ensure that extension cords are not needed to reach outlets, reducing the risk of tripping hazards and electrical overloads. In kitchens and bathrooms, the NEC has additional requirements for outlet placement. In kitchens, outlets must be installed at least every 2 feet along the countertop, and at least one outlet must be provided for each island or peninsula countertop space. In bathrooms, at least one outlet must be installed near the sink, and all outlets within 6 feet of the sink must be ground fault circuit interrupter, or GFCI, protected. GFCI protection is required in wet locations to prevent electric shock hazards. GFCIs are designed to detect ground faults and quickly interrupt the circuit, preventing a dangerous electrical current from flowing through a person's body. In addition to GFCI protection, arc fault circuit interrupter, or SI protection, is also required in many areas of the home. SIs are designed to detect arc faults, which are a common cause of electrical fires. SIs can detect small arcs of electricity that may not be enough to trip a standard circuit breaker, but can still generate enough heat to ignite nearby materials. The NEC requires SI protection for branch circuits supplying outlets in bedrooms, living rooms, dining rooms, and other areas of the home. When installing electrical wiring in walls, it is also important to consider the presence of other utilities, such as plumbing and HVAC systems. Cables should be routed away from water pipes and heating ducts to prevent damage from moisture or heat. Additionally, cables should be protected from physical damage by installing them behind wallboard or other protective coverings. Before starting any electrical work, it is essential to turn off the power to the circuit being worked on. This can be done by switching off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to test the circuit to ensure that it is energized before touching any wires or terminals. A voltage tester can be used to verify that the circuit is not live. When working with electrical wiring, it is important to use the proper tools and equipment. Wire strippers should be used to remove insulation from wires without damaging the conductors. Pliers and screwdrivers should be used to tighten connections and secure wires in place. Electrical tape should be used to insulate exposed wires and connections. Safety glasses and gloves should be worn to protect the eyes and hands from electrical hazards. In addition to the NEC, local electrical codes may have additional requirements for electrical wiring. It is important to consult with a qualified electrician or building inspector to ensure that all work is done in compliance with local codes. Failure to comply with electrical codes can result in fines, penalties, and safety hazards. Finally, it is important to remember that electrical work can be dangerous. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with all applicable codes and regulations. By following these guidelines, you can ensure that electrical wiring is installed safely and correctly, protecting your home and family from electrical hazards. Remember to always prioritize safety and consult with a qualified professional if you have any questions or concerns. The NEC, specifically Article 314.17, dictates rules for conductor entry into boxes, conduit bodies, or fittings. Where non-metallic sheath cable or multi-conductor cable is used, the cable assembly, including the sheath, shall extend not less than 25 inches through the opening into the box. The cable must be secured to the box or fitting such that there is proper strain relief. An exception to this rule is where cables enter from the rear of the box through a knockout that is specifically designed for cable entry. In these cases, the cable does not need to extend 25 inches into the box. Furthermore, Article 334.30 covers securing and supporting non-metallic sheathed cable. Non-metallic sheathed cable must be secured by staples, cable ties, straps, or similar fittings designed and installed so as not to damage the cable. Cables must be secured within 12 inches of every box, cabinet, or fitting, and at intervals not exceeding 4½ feet along the run of the cable. Horizontal runs of cable installed in the board or punched holes or notches in wood or metal framing members are considered supported and do not require additional securing. There are exceptions to these rules as well. For example, inaccessible attics or roof spaces, where the cable is run across the top of floor joists, or across the face of rafters, the cable must be protected by guard strips where the attic or roof space is accessible by stairs or a permanent ladder. Another exception covers short runs of cable. If the cable is fished between access points, such as behind finished walls, and no access is possible without damage to the finish, the cable does not need to be secured or supported. Furthermore, for cable lengths not exceeding 3 feet from the last point of cable support to the point of connection to a luminaire or other piece of equipment, securing and support is not required. The NEC also addresses the protection of cables from physical damage. Article 300.4 specifies requirements for protecting cables and raceways from physical damage. Where cables pass through holes or notches in framing members, they must be protected from abrasion. This can be achieved by using grommets or bushings to line the holes, or by installing the cables in a raceway such as conduit. Additionally, cables installed in locations where they are exposed to physical damage, such as in garages or basements, must be protected by conduit or other approved means. When running cables parallel to framing members, they must be installed at least 1¼ inches from the nearest edge of the framing member. This protects the cables from being damaged by nails or screws driven into the framing member. If the cables cannot be installed at least 1¼ inches from the edge, they must be protected by a steel plate or sleeve. Article 314.23 covers the support of boxes. Boxes must be securely supported in accordance with the NEC. Boxes that are mounted to framing members must be supported by screws or nails. Boxes that are mounted to masonry or concrete surfaces must be supported by anchors or fasteners suitable for the application. Boxes that are suspended from ceilings or walls must be supported by hangers or brackets designed for the purpose. The type of support used must be adequate to support the weight of the box and any equipment or devices that are installed in the box. In addition to these general requirements, there are specific requirements for supporting boxes in certain applications. For example, boxes that are used to support ceiling fans must be listed for that purpose and must be supported in accordance with the manufacturer's instructions. Boxes that are used in wet locations must be listed for wet locations and must be installed in a manner that prevents water from entering the box. Proper box support is essential for ensuring the safety and reliability of electrical systems. Poorly supported boxes can become loose over time, leading to loose connections, damaged wires, and potential fire hazards. When in doubt, it is always best to consult with a qualified electrician to ensure that boxes are properly supported in accordance with the NEC and local codes. Always use appropriate fittings and connectors for the type of cable or conduit being installed. This ensures a secure and reliable connection that will not loosen or fail over time.